Hello and welcome back. Today's video is going to cover graph manipulations in sinusoidal graphs as it relates to what's tested on the ACT. As always, if you find it helpful, leave a like, subscribe if you want to help me out, help the channel, or help others find the videos, and leave comments with anything you like or anything you'd like to see more of or any questions you might have. But let's get straight into it. We're going to start here with the graph manipulations. So what are we going to have to do with these on the ACT? Not too much, there's only two real things. So if we're given some function, f of x, we're going to have to match a graph or equation to some manipulated version of that function as a result of either translations or reflections. It's just those two, really, that we're going to be seeing. They don't really test rotations because that's a bit more complicated than what's actually going to be tested here on an ACT. So let's start with the translations. This is the most common of the two that you're going to be tested on. So what do I mean by a translation? That's just sliding a graph to the left, right, up, or down. So it's not going to be stretching, it's not going to be shrinking, it's not going to be spinning or anything like that. It's just sliding around. So for our examples, I'm going to use y equals x squared, or just a general f of x as the starting function. The reason I put f of x in here is they might give you this formatting of saying, hey, if I have f of x, and then this turns into this, which I'll have some examples before, what's it going to do? So how do we actually do translations? So one way is you add or subtract a number from inside the parentheses with x. So in that f of x format, that would look like this. F of x plus 1. It could be minus 1 or any other number, but it's inside the parentheses with the x. You're using the y equals x squared example, it would look like this. That x squared becomes x plus 1 in parentheses squared. So what does this do if I add or subtract something inside the parentheses? That's going to move it left or right in the opposite direction of the sign. So if I have plus, it's going to go to the left. If I have minus, it's going to go to the right. So in these examples, it's actually going to move the original function to the left one spot. The other choice is to add or subtract a number from outside the parentheses with x. So again, in these examples, now we take that plus 1 and we put it outside the parentheses. And where we had x squared, we do a plus 1, but we do it after whatever is being done to x. So where this up here in the parentheses went left or right, this outside the parentheses is going to go up or down. And also it's going to change the direction. Instead of going opposite of the sign, it's going to go the same direction. So now plus means up and minus means down. So these two examples that have plus 1 outside the parentheses are going to both go up one spot. So let's look at some examples. Again, we're going to start with y equals x squared. So that you have this nice curve that intersects at 0, 0. So let's look at left right here. Let's start with the red. Here I have minus 2 inside the parentheses, so that tells me it's left, right, and it's opposite direction. So minus 2 means I'm going to go to the right 2. So instead of intersecting here at 0, 0, I go 1, 2, and here it is. The opposite of this then is the blue, where I have plus 2 inside the parentheses, so that's going to go left 2. Now here's the same examples, but now with it being outside the parentheses, so I'm going to go up and down in the same direction as the sign. So the red being minus 2 is going to go 1, 2, down. Whereas plus 2 in the blue is going to go up 2. So that's all there is for translations, but they're very important because they're one of the most commonly tested of all of these graph manipulations. So now let's go talk about reflections. Much less common, but I have seen them. And what that means by a reflection is I'm just going to flip a graph, either left, right, so that would be across the y-axis, or up and down, which would be across the x-axis to give its mirror image. So again, I'm going to have some examples with the f of x format, or I'm going to use x cubed. When I get to the actual images, I'm going to switch back and forth between a few different things just so I can show it a bit more easily. But for this slide, these are the two I'm going to start with. So how do I reflect an image? So here, I'm not going to be adding or subtracting, I'm just going to be putting a negative somewhere. So if I put that negative inside the parentheses, so just like before where I was adding plus 1, inside the parentheses. This time I'm just putting a negative in front of my x. So if it's inside my parentheses, that's going to flip left-right across the y-axis. So when I say flipping, give a mirror image, you can think of, take that y-axis, as on a fold on a sheet of paper, and you were to fold it over. If the graph is on your right-hand side of that line and you fold it over, it's going to smack onto the left to be its mirror image. The other way you can do it is put that negative outside the parentheses with x. So here's that example. So we take that negative and we put it outside. So it's to the left of the f, or we put it before we do the x cubed. So whereas this went left-right, this is going to go up-down across the x. So that's where, again, you're going to fold your paper, but you're going to fold it from top to bottom or from bottom to top across using that x-axis as your folding line. So these might make a bit more sense with the pictures. So as a starting point here, I'm going to use x cubed plus 2. It's kind of funky looking, but this is where it is and what it looks like. So here, if I just go inside my parentheses and put a negative, that's going to flip left-right across the y. So let's start by the right-hand side. You can see I start at 2. I'm still at 2 because it's not going to move it around anywhere. But where I had this upward curve going to the right and up, now I'm going to flip this over here. So instead of going this way, it's going to go this way, and that's where I get this. And then this, which went to the left and down from the 2, now is going to go right and down. So again, if you were to think of using this as a sheet of paper and just folding it in half, anything over here gets shifted this way, and this will go shifted that way. Then let's look at the other way, flipping over the x up down. This is really easy to show with x squared, so I did that. So in red I have x squared, and then in blue I took a negative and put it outside the parentheses. So I have negative parentheses x squared. That's going to flip it up down across the x. So whatever was going this way is now going this way. And that's all you're going to have to know for the reflections. So now let's move on to sinusoidal graphs. These have a few different things you're going to need to know, but I wanted to put it with those graph manipulations because there actually is a connection point later on in our last slide, which is going to give us how do we get all these different parameters from the equation of a sinusoidal graph. But we'll get to there at the end. So first of all, what do I even mean by a sinusoidal graph? So those are just graphs of sine of x or cosine of x. They really don't test tan of x, but sometimes you might see it. So if you wanted to look at what that looks like, feel free, but I'm not going to cover that here because it's extremely rare that you're going to run into that. So what are you going to have to do with these? You're going to need to pick the amplitude or the period of a given graph, or you might have to give the amplitude or period from a given graph, or you're going to match a graph and equation. Oh, and sorry, I misspoke earlier. Because I said given graph both times, so these would have been the same thing. This is giving the amplitude or period from the graph. The second time I meant to say give the amplitude or period from the equation. That way they're actually two different things. Sorry about that. So let's start out with just what do these graphs look like. Here's an example of y equals sine of x. So you're going to have this waveform. This is it in radians. This is the same thing in degrees. It looks like it's more stretched out here, so it's different in degrees. It's actually the exact same graph. I just stretched my picture a bit so you can more easily read these numbers. But you can see for sine of x here, it crosses at 0, 0, then again at pi and 2 pi. So if you were to think of completing an entire cycle of all the way up, down, and then back up to the starting point, it does that in 2 pi. In degrees, that's the same thing at 360. So they're not normally going to have you choose between sine or cosine, but just in case they do, I wanted to cover what the difference is, because they're the exact same shape, but they are offset to the left or right. So the easiest thing to do is use that y-intercept to identify them. And this is going to assume that there isn't something in the equation that is shifting it left or right. If that is the case, they're normally not going to have you choose between sine or cosine. They're just testing then that offset. But to know the difference, if I use the y-intercept for sine in red, it's at 0, whereas cosine, it's 1. So that's all you're going to have to know really to be able to choose between them. So now, what do I have to know if I have a graph? First of all is amplitude. This is by far the most common thing they're going to test. Is they're going to give you the graph or the equation and ask, hey, what is the amplitude? And all that's going to be is the distance from the horizontal center line, so that's the x-axis, to the top or bottom of the peak. So distance from here to here, or here to here, it's going to be symmetrical, the same either way. Now, if this thing is shifted so the entire center point's at a higher or some other point other than 0, it's not always going to be the x-axis, but this is going to be the distance from whatever its centerline point of symmetry is. Usually they don't shift it so it is the x-axis, but just know it can shift the entire thing up. If the amplitude is larger, it's going to just stretch these even higher, whereas a smaller amplitude is going to have less distance there. The next thing you'd have to know is just the period. So that's going to be the distance in x to get from one point of the pattern to the next repeat of that same point. So the easiest way to do that is to go to the top or bottom, and be like, okay, from here at the top to here at the top, it took from negative 3 pi over 2 to pi over 2, that is 2 pi. So the period would be 2 pi. Now, notice I used the top there. You could use the bottom and do the same thing. I would always do that and do not use the x-intercept. So something like here, one of the most common mistakes I would see is people go to, say, this point, and be like, oh, well, the next time it crosses is right here. So 1 pi, that's the period. But that's not true, because while, yes, I get to the same y value of 0, it's not the same point in the pattern. Because here, if I'm going left to right, the graph is going down. Whereas at this point, left to right, I might still be at 0, but now I'm still going up. So I'm only halfway through. If I wanted to use this towards going down, I'd have to keep going past this point to here, where I'm at 0 again and still going down. So it's the exact same repeat of the pattern. So the easiest way to avoid that mistake is just use from top to top or bottom to bottom. And then you don't have to worry about it. The last thing I wanted to put on here is something that I haven't ever really seen them test, but since the graph does change and I haven't seen every single test ever, if they do test frequency, it's just 1 over the period. So you just get the period and do a fraction of 1 over whatever that was. So finally, I wanted to go to the basic equation of the graph. So they might give you the equation and ask you to either pick the graph from the equation, or they might ask you something like, what is the period or what is the amplitude from this? So we'll go over what all these A, B, C, and D's mean, and you can use that to either directly answer the question or to find the graph that matches those properties. So again, y equals A sine of bx plus c plus d. You're not always going to see all of these. If there's no c or d, it will just be A sine of bx. It's not always going to be plus 0 or plus 0. These might just go away. But these are the 4 places where you might see a number. For A and B, if there's nothing there, they're just 1. So let's begin with A. That's the amplitude. It's the easiest one and by far the most commonly tested. It's just whatever number is in front of the sine or the cosine, that's the amplitude. And usually that's all they ask is, what's the amplitude? Just find this number and that's your answer. Very quick, very easy. Again, if you don't see a number in front of the sine, it's 1. So now let's look at C and D. I'm skipping B because that's the weirdest one. I'll come to that at the end. Now, C and D follow translation rules as we covered earlier in the video. That's why I wanted them in the same video. So notice, C, this is being added inside of parentheses with an X, whereas D is outside the parentheses. So D, start there, that's vertical up-down shift in the same direction of the sign, just like any of the other translations. Adding something outside of the parentheses of X with its function just takes the whole graph and moves it up or down in the same direction as the sign. Whereas C, that's the horizontal, left-right, in the opposite direction. Now, this is a lot harder to see since these things go on infinitely as a wave. So the easiest way to see that and pick it from the graph is if I have sine, which remember, crossed at 0, crossing the y-axis, I should say, at 0. If this says plus pi, well now I need to make sure that it's crossing at negative pi, which is a poor example because it already did that. So in that case, you're not actually going to see anything. But if it say plus pi over 2, then it needs to cross over there. So that's the difference. And I guess, sorry, I'll take it back. The plus pi would still work because instead of it going up and down, it would only be halfway of a shift. So there would be a difference there. It would just be which way it's going at that cross. Doesn't really matter though. Main thing is C is the left, right, and the opposite direction. Sorry, I kind of went on a tangent there. Now, you'll also see I have here or phase shift. So in their phrasing, they might call it a horizontal shift, they might call it a phase shift, or a shift to the left, or a shift to the right. Those all mean the same thing, it's just different terms. The final thing I want to talk about is B. That's the weird one. It's not hard, it's just not as direct as these. The value is this, that's the amplitude. How much does it shift up? The value that's right there. How much does it shift left or right? The value that's right there. B, you have to do a little bit more to it. Because what you can get from B is the period. But you have to do a little math. So if you are in radians, the period is going to be 2 pi over B. So the easy way to remember this, if you have the basic starting period of sine or cosine, if it's just sine of x or cosine x, the period is 2 pi. So if I have B with nothing there, that's sine of x, but that's a 1. So that's 2 pi over 1. If you do have a number in here, you still have that starting point of 2 pi, but you're going to be shrinking or increasing, depending on if it's a fraction, what that period is. So whatever number you have here, just do 2 pi divided by that number. That's your new period. Now if I'm in degrees, I don't work with 2 pi anymore. The original period was 360 degrees, not 2 pi. So in that case, it's just going to be 360 divided by b. So that's all you have to know for the sinusoidal graphs. You can use these to either just directly ask, if they ask, well, what is the period? What is the amplitude? This is how you can get it. If it's matching a graph, go find the one that has the amplitude of A, then go to your C and D to get your offset. That's usually enough, but if you have to, then you can get to the period and choose from the last few remaining. But that's all that we have to cover today. Good luck. Hope it helps. I'll see you on the next one.